Hi, welcome to the channel Coders Arc, where we unravel the world of coding and architecture together. And today I'm going to talk about a very important topic in the field of large language models and Gen AI called the Retrieval Augmented Generation or RAG. I will show you how the RAG architecture is implemented in AWS, and I will also share some code snippets at the end of this video in Jupyter Notebook. But before we understand how the RAG architecture works, let's first understand what RAG architecture really is. The term RAG or Retrieval Augmented Generation clearly indicates the meaning and purpose behind it. Let's break it down. The generation stands for the generative AI aspect of the large language model. Augmented stands for improving, enhancing, or augmenting the capability of a system so it can better respond to the requests. And finally, the term retrieval means fetching the pertinent facts about a system from an external source of truth. When you combine the three, it becomes retrieval augmented generation. Now, this is the architecture that I will be covering in more detail. As you can see, it's a multi-tenant architecture, and there are many customers on the left side. They will be sending queries to the system so that you can get an accurate response. But before I dive into the details of how this architecture works, let's revisit some of the concepts that we had discussed in the past. I want to remind you one more time about the basics of vector embeddings. Basically, you're looking at a three-dimensional vector space where the words that have similar meaning are placed close together in this space. This is only three dimensions. In reality, for large language models, you have hundreds of dimensions, and words, phrases, and sentences that have similar meanings are placed close together in that space. If you want to learn more about the basics of vector embeddings, please watch one of my older videos where I cover it in a lot more detail. Some other important facts about LLMs that you must know before we dive into the RAG architecture is that large language models are essentially neural networks that work with the numerical representations of words and phrases. Large language models do not store facts, but instead they store the probabilities of the outcomes. It takes a long time for large language models to train. Remember this fact because it is essential why RAG architecture is so useful. An LLM also has limited context window length. This is another important fact to remember on how the RAG architecture is useful. I will cover both of these points when I dive deep into the architecture. Now, with all the basics covered, let's take a much closer look at the AWS RAG architecture. Before we dive into the virtual assistant query API workflow, let's take a closer look at the bottom of this diagram. This is a precondition step where all the corpus documents have been first split into meaningful chunks with some overlap to maintain the context, and then they have been converted into vectors and saved into the vector database. An Amazon SageMaker processing job is used to convert the corpus documents to word vector embeddings. An Amazon OpenSearch service is a vector database, which is nothing but a serverless multi-tenant vector search DB. Now, after all the corpus documents are saved into the OpenSearch vector database, now we can begin the virtual assistant query workflow. Essentially, the customers are going to make a human readable English query to the Amazon API gateway. An API gateway will be hooked up to the AWS Lambda using the Lambda proxy integration. Essentially, the question will now be converted into its vector embedding using one of the new Amazon SageMaker endpoint. Now, one very important thing to note over here is that the AI model used to convert the question into its vector embedding is the same AI model that we used to convert the corpus documents into their vector embeddings. Why is this important? This is important because when you compare the two vectors, the question vector against the corpus document vectors, you need to do some kind of a similarity score search so that you can find relevant content to be fed to the LLM as a prompt. Finally, after all the relevant document vector embeddings have been extracted from the vector database OpenSearch, What is fed to the large language model is the original question plus the matching vector embeddings. As usually there are about 3 to 5 document sources that are fed to the large language model. Now, the large language model has the entire context to answer the question with facts instead of answering the question with probabilities. Now, if you remember in the earlier part of the video, when I was covering the basics of LLMs, I was talking about there are two questions in your mind. Why can't we just retrain the entire model so that it knows how to answer the questions based on the corpus documents? Yes, that is a good option, but why it's not done is because it takes a long time for the large language models to be trained, and it takes months and months. And that's where RAG architecture is so powerful, because you don't have to retrain the entire model. You just make sure that you provide the appropriate context to the large language model along with the question so that it knows how to answer the question appropriately. Now, the second question you must have had is, why don't we pass the vector embeddings of the entire corpus documents to the large language models instead of passing just 3 to 5 matching vector embeddings? Why we don't do that is because the large language models have a limited context window size. If you pass documents or vector embeddings that exceed that token limit for the large language models, you are going to get hallucinated responses. So instead, what we do is with the RAG, we find the matching documents that have similar meanings to the question and then submit just a subset of the corpus document vector embeddings to the large language models so that the answer could be more crisp and relevant. Essentially, large language models work very similar to how human brain works. Human brains can only operate with a limited context. If you are doing multiple tasks, the quality of your work gets degraded. Similarly, if you expand the context window size of large language models, the accuracy and correctness does not improve. In fact, it actually declines. So making the context window is not a good option. Instead, use the power of RAG architecture where you give the appropriate context in the prompt and let the large language model respond appropriately. With this, we've covered the theory for the AWS RAG architecture. Now I want to walk you through some code snippets in the Jupyter notebook and run the code to show you how the RAG architecture works step by step. So let's dive right into it. So here, now I'm on my Jupyter notebook where I've implemented a virtual assistant using the RAG architecture. The first thing that you see over here on the top is I've installed all the necessary packages from Python that I need to execute my code. Next, you see that I've chosen the Meta's Llama 2 model as my LLM. I run it on an EC2 instance of G5 2x large size. It's a SageMaker instance, nothing but a compute instance that has high computing power to perform the large language model task. I deploy the model on a SageMaker endpoint. I've already performed these tasks because it takes a few minutes to complete. Next, I've defined the content handler class, which has two methods, transform input method and transform output method. If you look closer, it's basically telling how the LLM should respond to your request. I'm stating, please respond as if you're a kind robot, but you can use any other direction. For example, you can tell the robot to respond as if it is a medical professional, or respond with sarcasm, or respond with less than 500 words or less than 1000 words. Whatever you want the LLM to respond as, you state it over here. Then also there are some parameters that you pass to the LLM. What's the max new tokens, 1000 tokens that it can take in a particular request. Temperature, essentially temperature controls how creatively you want the LLM to respond as. A higher temperature value means the LLM will respond with a lot of creativity, but a lower temperature value means it'll stay more grounded to the facts. Finally, I want to come to the part that is more relevant to the RAG architecture. If you see carefully now, I have chosen a bucket name from where I will be reading my corpus documents. In my case, I'm just parsing one PDF file. I parse that PDF file one page at a time, and you can see that this PDF file has about 12 pages, and it's nothing but a quality report for a drug, Tylenol. It's a hypothetical report that I've created, and I just print the data in the end so you get context of what the data is about. Then finally, I store the corpus embeddings into the vector database. Here, you can see this is some of the basic Python syntax to recursively parse through the documents with some overlap. This is done so that you're preserving the context. And then finally, this line of code, I'm not using the open source database just because I'm trying to illustrate the point. You use a Chroma DB, and where you store all the embeddings that have been converted from this documents into the database using a proper index. And finally, I do the retriever setup. This is needed because we will be using this in the lang chain. So here I define that the search type is MMR, and I just print it. So you can see that I'm using the Hugging Face embeddings. Essentially, you can use any embeddings. The important point to note here is that the embeddings that you use to embed the documents is the same embeddings that you will use to convert your question into embeddings. And finally, I go to setting up the LangChain for query execution. LangChain is nothing but a framework designed to simplify the creation of GenAI applications using the large language models. This is where all of the things come together. As you can see, I'm setting up a chain type with chain type as stuff. You can set any other chain type like conversational chain, QA chain, summarization chain. There are many other chains. You can read more about it in the documentation for LangChain. I'm choosing the LLM model over here. This is the Llama 2 model that I had set up previously on my SageMaker endpoint. And then I'm choosing the DB handler as the vector DB handler over here. And then I'm specifying that the document, uh, whenever the LLM responds, it should include the source documents in the response. So now I'm ready to perform the execution. Here, as you can see, I'm querying a hypothetical pharmaceutical report, and I'm asking a question: can you kindly create an executive summary for my current report? What happens behind the scenes is this question gets converted into word vector embeddings. We have the DB handler for the Chroma DB, and the vector embeddings for this question are compared against all the vector embeddings that are there for the corpus documents, and about 3 to 5 matching vectors are chosen and passed to the LLM as a prompt. So you're passing the content of the query and the content of the matching vector embeddings to the LLM. And then finally, you make the execution call result equal to QA, which is the LangChain query. And then finally, once you get the response back, you can see that the LLM has responded back as a kind robot. Now, if I want to view the source documents that were used to answer this question, you can see that I call results source documents, and it includes the references. So it includes, as you can see, there are 1 reference, 2 reference, 3 reference. So it shows like what parts of the documents or what parts of the vector embeddings were considered while answering the questions. I can ask more questions over here, and essentially you can play around with the question as you want. So that's all that I wanted to cover in this video. So hopefully now you understand the RAG architecture in detail. You understand how it works and what it is. Hopefully you are also able to understand through the code how it's implemented in Python. And you understand the power of RAG architecture. You don't have to retrain the model entirely to get the context passed to the LLM. And you don't have to also exceed the context window size. We covered both of those points in detail. They are very, very important for the RAG architecture. So if you found the value in this content useful, please hit the subscribe and the like button. And if you have any more questions, please ask me in the comment section. I'll be more than happy to answer. Goodbye for now.